used. How many guys here have ever lost their subs?
I've never done that.
Yeah, right. I have. I know one of my boats spent 3 days at 30 feet before I could get it back. And it's a mighty empty feeling to go home with only your boat stand. I mean, it's like losing one of the kids. It's worse than losing one of the kids.
That's not talk back.
It's true. So I think probably my biggest contribution to this particular gathering today is the fact that I have for each of you a diagram and a parts list to build a fail-safe system, which is a missing pulse detector. Some of you have those already. Those of you who don't will have at least the parts list and diagram before you leave today. I got a copy for everybody. Skip has a lot more information than I did. I couldn't get everything. I couldn't transport everything from California. So.
You could buy a larger RV.
Only if you make the payments.
So feel free, open up, talk. Let us know what you want, because even if Mike and I can't help you, maybe Bud can, or Bill Rohr, or whoever, anybody.
Where can you get those little diaphragm seals?
These?
No, not those, not the boots, but the yes.
Well, go down to your local carburetor rebuilder. That's a vent valve. That particular is a vent valve from on a 1920 Holly one barrel carburetor. I used to have a carburetor rebuilding business, so I have a bunch of those. The bellows. This bellows here, which seals the piston itself, that's a seal for a quadrijet carburetor accelerator pump, early style. But that's what is it, blue line, or
They sell them commercially.
yeah,
Right.
it's a little bit lighter material. This is heavier, but it's the same thing. Simplest would be a dynamic diving system.
Okay, and then for wanting to ballast your boat
Then whatever, it's going to be a matter of pumping water in, it's getting water into it and getting water back out of it in some way. But there is no simplest.
So if
it's still going to be a matter of personal preference.
if you're going to use a pump system, what pumps are you using?
That's your area.
His NRC pumps are very good, I think.
There's several pumps in the market that are very good to pump in, pump out. I think that the one that they advertise, probably the greatest one for both the DeBoer kit and for 32nd parallel, comes from an RV rig. It's called a shear flow, and it works very well. It'll pump a lot of water real quick.
Something to look at there really is the size of the boat as well. Something in Bud's lane, something that's good for Bud's lane would be too much for a boat this big. Okay, the reverse of that is something that's good for a boat this big. A windshield washer pump would work well with a boat the size of Jerry's, the 32nd parallel 23. But the Trenco windshield washer pumps are available at parts stores all over. A Trenco windshield washer pump would take about 3 days to pump enough water to fill Bud's ballast tank. So it depends on the size of the tank.
When you said the size of his boat, is his boat about 6 footer?
That's 10 feet, a couple inches short of 10 feet. Okay,
That's
so
right, 32nd parallel.
holds about a gallon, is it, the ballast tank? Holds about a gallon of water, so take it from there.
I think this gentleman in the back had a question.
Yeah, okay. It's easy enough to understand how compressed air works, venting the ballast tank, warming the water back out. My question is, with using the pump system, you pump to flood the tank, and then you surface, plane back up to the surface to where you can get some kind of
An air source.
an air source, and then you pump the air back in. Okay.
You pump, what it is, you're always pumping the liquid, you're always pumping water.
Right.
So you're pumping the water in, but the air is being pushed out the top.
Right.
Through a periscope or whatever. When it's reversed, now you're pumping the water out and air is coming back in through that periscope. Shortcoming with that system is, if you get hung up in weeds, There's no way to get air to it.
Right.
You have to go for a swim.
What about using air that's trapped in an air box inside the hull?
That is basically the Darnell system. Okay, it's got an air bladder, and it's got a pump, and it pumps the air out of that bladder into the watertight box, into your pressure hull. Okay, which then, you know, that ballast tank, that bladder has collapsed. Now water is taking its place. The boat is heavier. It's a balloon.
In other words, a balloon inside of a tank. When the balloon is deflated, the tank fills with water. When the balloon fills up, it pushes the water out of the tank.
Yeah, exactly.
Makes sense.
Fish like it too.
And you don't need a check valve or anything else either.
You need a check valve in the pump system?
No, because the valve itself serves as a check valve.
Right.
You put it in the swimming pool.
I'll be absolutely honest with you. I personally have never done any computation. Yeah, that looks about right.
T&E, Charlie.
I've come very close on occasion, and as Bud will tell you, I've been way out in left field. There was, 4 different versions for Bud before we finally came up with something that was close to being right. So,
Do you use
Michael has a method. No, go ahead.
Do you use one tank or 2 tanks, fore and aft, or tank central?
Either way. You can do either one.
You can do either way. My personal preference is a central tank, single tank. And I'll explain why. With 2 tanks, you're basically looking at 4 and aft. Bow and stern. Now, to get a realistic dive, the bow takes a slight angle down and glides down in reverse. When it surfaces, the bow is up a little bit. Almost every boat going, especially the newest, they're fat up in the front and they're skinny in the back. A Type 7 is, a Type 9 is, the fleet boats. So what that means is your ballast tank in the bow has to be a little bit bigger. And the stern is a little bit smaller. Now, theoretically, what will happen if both tanks are the same size, or even if the vents are the same size, top and bottom, they'll both fill about the same. And now you're going down by the stern. You're coming up by the stern. Okay? So to offset that, you have to close your vent down a little bit. Or if you're using pumps, you have to slow the water down, slow the pump down. And there's too much T&E
Adjustments.
as far as that's concerned. And in actuality, you don't need that. In a full-size submarine, the main ballast tank is midships, in the midships section of it. It's trim tanks that are fore and aft, which we do the trim with little pieces of lead here and there. But once the trim is set, that's it. You don't go any further.
Skip, does that apply for all subs, whether it be nukes or the fleets or?
My experience has been, all. But a single tank, now you also only have one system. Because let's face it, Murphy always comes into the picture. Okay, if there's something that can go wrong, it will. If you got 2 tanks, 2 systems, you got twice as much chance of getting something to go wrong.
Makes sense.
So, but this is my way. This is my preference. This is what I've worked with. This is what I'm happiest with. Mike's done things differently, and it works fine for him. I'm sure there are others out here that have done the same thing. It's really a matter of what you're comfortable with. I'm a firm believer in the KISS principle. Keep it simple, stupid. It works, believe me. Right? No comments from you.
Before we get back in here, the gentleman had a question about what the size of a ballast tank should be. One way that you can figure that out is to take a hull where you first did it. Okay, I'm assuming it's like a 32nd parallel hull or something like that. Take it. What I do is go out and I submerge it in water, or just fill it full of water, and then I weigh it and see how much water this hull is actually holding. Okay? Before you drill any holes or anything else, just weigh the water that's in it. Then I go over and I empty it all out, dry it all out, and I take all the lead that I'm going to put in this boat and all the batteries, because the batteries are the heaviest things. And if you have a few servos, speed control, and everything else that you're going to put in this thing, I pile it in the boat. And then I sit there and I get a small container of, usually a small container of water, and I put that in the boat until the boat gets right down to where it's just ready to go under. Then I take the boat out of the water and I weigh this. And I know that this is how much stuff that I'm going to have to come up with, how much weight. Okay, and if you know how much weight that is, you can go to Mother's Cookbook, which is where I usually go, and you find out what the weight of water is. I think it's 7 pounds, something like that a gallon. Take that.
Salt water or fresh? Fresh it does, buddy.
Yeah.
8 pounds, something like that.
Salt, something like 7, which is where, but that's okay. At any rate, you take that, and then I know that that's how much water that this tank's going to have to hold. It's going to have to displace this much with all the stuff in it. I know the difference between the two. And it gives you a starting point. Sure, it's a rule of thumb, and you can be off a little one way or another. But you can use a little styrofoam, or you can use a little lead shot to make up the difference. But it'll give you a starting point, and that helps. And sometimes it's a little better than, well, I think. General dynamics doesn't work on, well, I think.
Mike, I gave Dave today an article from 32nd Parallel when they first were putting their below the periscope or something it's called. And it uses a system similar to you. It said, build a boat and basically put all your parts in it, sink it to where you want it, okay, and then raise it up with like a sling and a scale, what that weight is, and then they gave you a formula for building the tank based on you times one number by another divided by 231, and it would tell you the cubic inches of ballast tank that you needed. And as I said, I gave that to Dave today to put in the archives.
Well, I wasn't into a whole lot of dividing and everything else, but the system I came up with worked fair for me, so kind of go from there. If you want to get more complicated, go talk to your your kid's 5th grade math teacher.
With the central ballast tank concept, is it advantageous to have that tank a little bit forward of center so that when you dive you have a bow down, and when you pump out you've got a bow up attitude?
No, not necessarily, because with that, when the tank is fully blown, the boat's actually going to sit bow high. Okay, but the tank will be ahead of the center line for that same reason. There's more displacement in the forward half of the boat than there is in the after part. So you have to compensate. What I've done there, I didn't know. This tank, I don't know if you noticed, it mounts on 2 little pads. I can adjust it. Okay, I can move it fore and aft. Just little pads on the bottom, a 1/2 inch or 1 inch separation in the holes, and just move it. If it's too far back, move it forward, and vice versa.
About what size boat would that tank that you just held accommodate?
That tank has been in my 23 and in the 2, and they're quite a bit different. But with this particular, take a look at it later. This bulkhead right here has been shoved in for the 2, because the 2 doesn't need as much. So created some problems with the Freon supply, but it works. And as a matter of fact, when it was in the 23, when I did need more capacity, I had a 1 inch extension down below. Plastic just to stick down into the keel, and it just adds a little bit of difference. As far as any computation is concerned, no, I didn't do any. I only tried this and it worked, so go with what works.
Put it by your head.
Yeah, that's it.
One other